Hello, 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 sir. Can you hear me? Hello.
Oh, yes, yes, I can hear you. Shall we start the
Okay.
session, Ravi
Yes, sir.
sir?
Yes, sir. We can start, sir.
Okay.
Just a minute. Okay. Okay. So, good morning to one and all. So, this is Praveen from the Technology
Shall I introduce
Solution.
yourself?
Oh, okay,
Shall
sir.
I introduce?
Okay.
So, welcome everyone to the second day of our FDP on LoRaWAN and IoT applications. Good morning to all of you. Hope everybody is keeping safe and fine. Today we have three sessions. So, the first session will be handled by Praveen Kumar R. He's a senior technical engineer in M2 Technology Solutions India Private Limited, and he has been working in this field for the past currently working as a senior technical engineer and previously worked as technical engineer in into technology from 2018, and he has been involved in designing many systems like IoT systems with Raspberry Pi, Python, LoRa communication, Zigbee communication, BLE, PCB designing, etc. And specifically he was involved in smart precision agriculture and SDAD, that is social distance alerting device using machine learning. Also BLE based smart ID card and LoRa based environment node. And we are extremely happy to have user with us today for our faculty development program. So on behalf of all the participants, I welcome you and handing the time over to you. Over to you, sir.
Thank you, sir. Thank you, sir. Okay. So, good morning, one and all. So, today, what are the things we are going to see now? So, what is LoRa IoT? So, why have to go for the LoRa IoT? What are the things is happening in the back end of those? How the data is taken and how the data is transferred without the internet? How can we transfer the data? So, all those things we are going to see on today's session. Okay. So, these are the things which we are going to see one by one. Okay. Okay. Okay, so this is the agenda. So, what are the things we are going to see? Introduction, LoRa IoT communication, and then gateway configuration. Those things are general thing. I'll explain later. So, what is gateway? What is node? What is network server? What is application server? And what is uplink, downlink? So, those things we are going to see one by one. Okay. So, this is the overall architecture of this LoRaWAN. Okay. So, what is this LoRa? So, why I have to go for this LoRa? Now, so for example, so if I'm deploying some sensor reading some physical parameter devices, I'm just planting in some agricultural field. Okay, so consider some 10 acres or 20 acres of field. I'm deploying some devices. Okay, so I want to take the data from that. Okay, so how can I take the data? So what is GSM? Okay, so consider in your place you doesn't have that much of GSM coverage. Okay, so only 3G or 2G only you are getting, and a number of things happening. Okay, and what happened if you are going with the Wi-Fi? What happened? So only 100 meters you can able to cover. If you're going with LoRa or LoRaWAN technology, so you can able to cover depending upon your environment is changing. Okay, so theoretically speaking, up to 3 to 7 kilometers. Okay, so sorry, practically 3 to 7 kilometers we have achieved. Theoretically speaking, up to 10 kilometers of radius. We can able to get the data. Okay, so that is the main feature of this LoRaWAN technology. Okay, so this is my architecture. How it's going to look like. So here you can see end nodes. End nodes is nothing but my sensor device, which is connected to a microcontroller and on LoRa module. Okay, so these three combined one we called it as an end node. Okay, on sensor. So for example, consider DSP18B20 sensor. Okay, it's a temperature sensor, right? Okay, so taking the temperature sensor data and connecting to a microcontroller, HTM8 or STM32 or else an Arduino. So likewise, I just connected to a microcontroller. Okay, on top of that microcontroller, I'm going to use one LoRa chipset. So, for example, LoRa 95. Okay, so that 95 with the help of that RFM 95 chipset, I can able to take the data and I can able to push the data towards the cloud. So that entire module is known as an end node. Okay. Then what is this use of the gateway? So here you can see one thing is called concentrator or gateway. So what is this gateway is going to do now? It's going to take the data from the node side, okay, and it will convert those data into an IP packets and it will transfer towards my network server or the application server. Okay, so in end node, how the physical data has been converted into your radio packets now. So from with the help of the sensor, what we'll do, I'll take the physical parameter and converting into some electrical parameters, right? Okay. So with the help of microcontroller, what I'm going to do, I'm going to convert those electrical parameter into a readable data formats, either analog or digital. So likewise, I'm going to convert with the help of that microcontroller. Okay. After converting those data, so what I have to do, I have to push the data towards that radios. Okay, so how can I convert those data packets into radio packets now? So with the help of an RFM 95 chipset, what I'm going to do, I'm going to take the data and I'm going to convert those data into one radio packets. Okay, so first one is a sensor and next one is a microcontroller, STM8 or an STM32 or it's an Arduino. So any microcontroller you can take. Sorry. So with the help of the microcontroller, what I'm going to do, I'm going to convert those electrical data into readable data format. After that, so with the help of the LoRaWAN or LoRaWAN or LoRa chipset, what I'm going to do, I'm going to convert those data into a radio packet. Okay. So after converting those data into a radio packet, it will emit those radio packet in a particular channel. So channel means frequency channels. I'm talking about frequency channel. So for example, 865402500. It's a one set of a frequency channel. So what it's going to do, it's going to take the data and converting those data into a radio packet and it pushing those data in that particular channel. Okay. So this is the thing what my end node is doing. Okay. Okay. So after jumping to a gateway, so what my end node done? So taken the data and convert the data into radio packets and pushing the data in particular channels, right? Okay. With the help of the gateway, what I can do, that gateways will listen on my particular channels. Okay. So consider 8 channel I'm having. So this gateway, multi-channel gateways will listening on the 8 particular channels. So what are the data it will come on that particular channel? It will grab those data and converting those radio packets into an IP packets because they have to push the data towards a network load. So okay, so with the help of a internet model like 3G or 4G, so I'm going to push the data towards the network server. Okay, so gateway end node, it doesn't require any internet. So from gateway to network server, if I want to publish worldwide, there only I require the internet. Okay, so here I can use 3G, 4G option, 3G, 4G option, Ethernet, Wi-Fi. So multiple options I can able to give via the gateway. Okay, so what it will do, these IP packets will forward to a network server. Okay, what is the help of the network server now? So this entire LoRaWAN communication will work on some uh, sorry. So this entire network server will work on a particular encryption method name is called AES encryption. So those encryption and data duplicancy, those things can be avoided with the help of the network server. Okay. Then after the network server, those data will hand over to an application server. Okay. So what is the use of the application server? It will store the data for data analytics. I want the data sets. I can collect the data sets from the application server and showcasing of our data. Okay. Those things we can able to do in application server. Okay. So these are the overall architecture, how my LoRaWAN is going to work. Okay. So LoRaWAN is a MAC protocol for a wide area. It is using a MAC protocol for a wide area network. Okay. So transferring the data in the internet. So it is using a MAC protocol. Okay. And most importantly, so this entire communication is a low power based communication. Okay. So it is transferring a long range, but how it is low power consumption? low power consuming devices now, because it is using a narrow band. Okay, so if you take your Wi-Fi or Bluetooth, so there you are using a huge bandwidth, right? Some 2.4 gigahertz of bandwidth here you are using. Okay, but here LoRaWAN. So what you are doing? So you are using a narrow bandwidth. Okay. So with the best example, if I want to say tell now, so if you are taking some water, if you are putting some bigger hole, the water will fall on 2 meter. So considering 2 meters, the water will fall. Okay. So if you are taking some pin and if you put the hole, what will happen in the bottom? So that water will fall on 10 meter. So that is the best example how we can able to visualize. So with the help of low power, with the help of narrow band, so it will transfer the data for a long range. Okay, so internet connected applications, so that works. So all the devices, if I want to control via internet itself, so from here itself I can give, if I want to turn on water or turn off water, I can able to send the data towards my node with the help of from the internet itself. Okay, long range communication. Okay, so that from the name itself we know that, so LoRa stands for long range. Okay, so in noisy layer where it stands for now, so first till third layer, this entire LoRa WAN architecture will follow. So first layer is LoRa and second and third layer is in LoRa WAN. Okay, okay, then it is using an ISM band. Okay, so ISM band it is using, so we no need to bother about any license for this. Okay, so it's a free one, unlicensed band it is using. Okay, so who is the authority of this particular LoRaWAN protocols? Na? So LoRa Alliance. So LoRa Alliance, you all aware about Bluetooth Alliance, those things. Na? So similarly, so multiple companies like IBM, multiple companies are using this as being a part of this LoRa Alliance. So the integrately created one protocol. So depending upon the protocol only, this entire devices is going to work. Okay. Okay, so hereafter I'm going to use a technical term like uplink and downlink. Okay, so what is the meaning of uplink now? So from end node till application server, if I'm transferring a data, that is known as an uplink. Okay, so from an uplink application server or a network server to an end node, if I'm transferring the data, that is known as a downlink. Okay, so this is known as an uplink and downlink. So end node, uplink means end node gateway. So using radio communication, so from gateway to network server using IP communication, whether internet or 3G or 4G or Ethernet or LAN or Wi-Fi, from network to application server. So if it is in downlink, application server, network server, then gateway, then end device. Okay, so this is known as a LoRa uplink and downlink. Okay, okay. So what are the modulation technique it is using? So if I want to transfer the data, the first thing is modulation techniques I have to use. Okay, so in this LoRa thing, so we are using a modulation technique is called a trip spread spectrum. Okay, so FSK with script spread spectrum. Okay, so we already know what is that FSK, frequency shift gain. So depending upon the thing, so it will automatically the frequency will shift. Okay, so those things then spread spectrum. So what is the spread spectrum? Spread spectrum. Why it is using that? So in spread spectrum, what happens? So that the entire data set it will convert it into data packets. Those data packets will transport in some parallel ways. So in node side, I can able to get the data easily. If it is a serial base, so I'm unable to get the data. Okay, so to increase the communication range, I'm using the spread spectrum. Okay, so where it is using first. So they have used in military appliance and space communication. They are using. Okay. Okay. So in this, the key things we are going to see in the further slides are spreading factor, frequency range, bandwidth, and other technical specifications. Okay. So like spreading factor, what is spreading factor? What is the use of spreading factor? What is frequency range is available in India, and what is it bandwidth? Those things we'll see one by one. So this is the technical spec of this entire LoRa communication. Modulation we already seen. Spread spectrum. So bandwidth. So actually, you just forgot about this. It is written wrongly. So it's starting from 125 kilohertz to 500 kilohertz. Okay. So bandwidth is 125 to 500 kilohertz, but in India we can able to use up to 125 kilohertz. Okay, its maximum data rate is 290 bytes per second is minimum, and maximum is 50 kbps. Okay, and maximum output power is 20 dBm, and link budget is 154 dB. This is an this is a theoretical value. If I'm using some 4 mAh of battery and I'm taking some 2 hours of data, so the battery will withstand for more than 8 years. Okay. So the power efficiency, so we already know. So this entire protocol and communication is using low power consumption. So power efficiency is there. Okay. So if I'm transferring a data towards an internet, so what is the main thing? Security. So for the security, so it is using an AES encryption method. Okay. The next one, all the devices are mobility, and the devices which I'm going to show in the picture. So those things are mobility. Okay. So this is it, LoRa and LoRaWAN structure where it is lies in OSI layer. So here you can see, so the physical layer, this entire LoRa communication will falls down. Okay. So what are the frequencies I'm going to do? So instead of using wires, so here I'm using the frequency channel to transfer the data. Okay. This LoRaWAN completely lies in this network layer. Okay, so in this LoRaWAN and LoRaMAC we have 3 set of things, so those things we'll see in the backend. Okay, so this is how my LoRa and LoRaWAN is allocated in this voice layer. So physical layer and then network layer. So physical layer, data layer and network layer, so that these things are located. Okay. Okay. So while starting the first slide itself, I mentioned that so it is using ISM band, which is a nothing but an unlicensed radio spectrum bands. Okay, so depending upon regions, the region authorities itself they will allocate these frequencies. Okay, so for Indian region, so here you can see these are the regional spec of that particular thing. So this is for European, this is for US, this is for China, and this for Korea, and this is for India. Okay, so these are the frequency channels, so which has been allocated by that particular thing. So for here, so this channel has been allocated by Troy. Okay, so those details we'll see in later part. Just a minute. Okay, so here you can see, so what is our Indian frequency? 865 to 867 megahertz. So we generally call it as an IN 865. Okay, which means Indian frequencies. Okay, so if you want to know more about these things now, so I'll show that where you can see. So if you want to know more about in-depth detail about this LoRaWAN spec, all those specs, so how the data is transferring, so how they are splitting the data, so you can see an website name is called www.LoRaAlliance. Okay, so here you just go. Okay, so this is that. This is the page for LoRa developers. Okay, so here a number of developers has given the spec, what are the Mac versions. So depending upon the Mac version, what are the things change, what is the frequency bandwidth, so what is the frequency channels for your region. Entire detail you will get from this website itself. So here, go to LoRaWAN. So here you can see an option called LoRaWAN for developers. So you just select this. Okay, and here I'm just scrolling down. So here you can see the layer standards, so backend interface, regional parameters, and certification, types of certification we can do. So here I'll just show regional parameter. So this is the regional parameter spec. So depending upon our region, the entire thing will be given here itself. So for example, so ours is India, right? So I'm going to type it as IN 865. So here you can see, so this is the entire detail, how they split the data, so how the thing is happening here. So all the, what is the power I can use here. So all the detail will given in this particular page itself. So here you can see what is our bandwidth. So in 865 to 867, 2 minutes of bandwidth. So if you want to see the preamble data formats, so you have to refer in session 3.0 physical layer. Okay. In what are the bandwidth and channel frequencies available? So these frequency channel and we are call it as a base frequencies. Means so whatever the devices LoRa and LoRaWAN devices you are going to use in Indian region. So if it is a multi-channel devices, so these three will be a base frequency. Okay, so remaining 5 frequency you can able to configure as per your requirement. Okay, so these things are base frequency, it should be available. Okay, and its bandwidth and data rate, and these are the 3 channels, base frequency channel I'm having. What are the channels na? 865062500 in hertz I'm saying. Okay, 865402500 and 865985000. Okay, so these are the base frequency bands. Okay, so this should be available for us. Okay, so remaining 5 band, so as per our requirement within this thing we can able to say. Okay, and one more thing, so I say it as so multi-channel. Okay, so 8 uplink channel, multi-channel means 8 uplink channel and 1 downlink channel we have. Okay, so consider 8 uplink channel and 1 downlink channel. Totally 9 channels available. So 8 channels is for uplink and 1 channel is for downlink. So what is the downlink frequency now? So my downlink frequency is 86650. Okay, so here you can see. So this is a constant one. So this one we are unable to change. Okay, default one. Okay, so this is my RX2 receiving windows fixed frequency and data rate. So my fixed frequency is 865550000. That's in heads I'm talking. Okay. So this is my for downlink one. Okay. So for uplink 865402500, 865062500, 865985000. In downlink 8665500. Okay, so this is for my downlink. Okay, okay. If it is spreading factor and bandwidth, if I want to take about the data, so spreading factor and bandwidth. So for your uplink channel, your spreading factor can start from SF6 up to SF12. It will automatically set if you are using ADR, adaptive data rate. If you selected, so it will automatically sets to SF6 to SF6 till SF12. Okay, so if we are choosing this particular downlink frequency, so by defaultly, what is its spreading factor? Its spreading factor is SF10 only, not not SF7 or 11 or 12. So it is defaultly, it is SF10. Okay. And if you want to see the data power, what are the TX power I can able to select in this particular thing. So here you can see. So TX power up to 18. So 18 is not 18. TX power is not. We can able to set, but it will radiate on more power. Okay, but as per trial regulation, so here we have selected up to 20 dBm, maximum 20 dBm we are setting. So for testing purpose, So we can able to set up to 38 dpm. Okay, but that is not suitable for deployment. So for deployment, we are using maximum up to 20 dBm only. Okay, so my TX power is 20 dBm. Till 20 dBm, it will transfer the data. Okay, okay. So here you can see. So this is the spec which I have shown there. Na? That same thing. So LoRa and bandwidth, base frequencies. So those things is already present. So here is a one set of frequency channel, so which I'm using for my nodes. So here you can see 865 062500 is a base frequency, 865 402500 is a base frequency, 865 9850 is a base frequency. Remaining frequencies. So here you can see 865 6025 and 86618, 86638 and 86658 and 86678. So these are customized frequencies, so which I have customized for my nodes. Okay, so here you can see. So my spreading factor for this is starting from SF6. Okay, consider as SF6. So SF6 up to SF12, we can able to set the spreading factor. Okay, and the downlink frequency is 86655 and then 4 zeros, and its spreading factor is 10. It's a constant one. Okay, and bandwidth is 125 kilohertz. Okay, so in uplink we are mentioning as an RX1, so which means window 1. Okay, so RX window 1. Okay, and this is for an RX window 2. So this is for downlink. So consider two windows is there, uplink and downlink. So this is an 8 channel for that RX1 window, and this single channel is for my RX2 window. Okay. Okay, limitation and where we can use this LoRaWAN technologies. Okay, so suitable cases. So if I want to transfer the data long range, there I can able to use. Okay, so if I want to you send the data long range with low power consumption, so I can able to do with that one, and low cost and bandwidth. Okay, so why I have mentioned this low cost now? So it's an initial deployment cost only. Okay, initial deployment cost you will get. Okay, after that, so maintenance, those things, you doesn't require any that much of cost. Okay, so consider if you're putting some GSM based modules. Okay, so okay, so GSM based some motor controller or like this, you just okay, so what happened? So every month you have to recharge, right? So maintenance cost, so consider you are recharging for 100 rupees. Okay, so consider in 12 months, so you are going to give some 1200. Okay, so instead of that, if you deploy the node, and instead of the consider you are having 100 nodes. Okay, so single node 1200. So if it is on 100 nodes, it's a huge cost of amount, right? So if you're going with a LoRa node, that same scenario, 100 nodes I'm going to deploy, and I'm having one gateway. From the gateway, I want to transfer the data towards network server. Okay, so on in between, so what I'm going to do, I'm going to use only one SIM card which is going to be present on that gateway. So only one recharge, some 300 or 400. I'm going to put 3-month pack. That entire 100 nodes data I'll get, and I'll transfer the data. Okay, so here I mentioned I'm having 8 uplink channel only. So how can I take the 100 data, 100 sensor data? No? So for that, from the node side itself, we have to you have to make the timing interval different timing interval. Okay, so like for example, for my first 8 node is transferring on some different frequencies on different timing interval. My second 8 node will transfer on different different frequency on different time channel. So likewise, they'll split this entire thing and it will take the data. Okay, so if the all node will transfer the data in a single frequency on same time, now it will not get. Only one data will arrive, remaining data will be lost. But so if I'm using the proper frequency channels and timing, so 100 nodes I can able to get the data. Okay, then So coverage, so if I'm deploying in an open space, so it's purely based on line of sight. If I'm deploying in open space, so I can able to cover maximum range of covering area I can able to cover. Okay, so if it is present in some dense area like cities, okay, so consider now I'm in Coimbatore, okay, so where I have deployed our gateway. No? So we have deployed our gateway in a fourth floor of my office. Okay, so there I have deployed my gateway. Okay, so in one side of the place, I can able to get nearly 3 to 3.5 kilometers of radius. Okay, but in another side, so I'm getting only 1.2 kilometers of coverage only I'm getting. So why? Because in this side I'm having bigger buildings. So a number of obstacles is there. But here in this side I'm having obstacle compared to this I'm having obstacles, not a pure direct line side kind of side. So but compared to this the buildings are very smaller. Okay, so attitude of my gateway is higher than that particular building. Okay, so that's why there I'm getting a number of coverage. Okay, okay. Then next one, it is using secured 128-bit encryption. So what is this secured 128-bit encryption? So we already mentioned that. So I'm using an encryption method. An encryption method name is called an AES encryption. Okay. So in this AES encryption, I'm going to encrypt the data and I'm going to push the data. So like this, previously I have mentioned. So those things, it is using an 128-bit encryption for this particular technologies. Okay, so where these LoRa and LoRaWAN is not suitable, where this LoRa and LoRaWAN is not suitable for this. Okay, so consider sending photos, images, videos, audios. Those things will not able to supported in this particular thing. Okay, so LoRaWAN connection because we are having only 125 kilohertz of bandwidth only. Okay, so that's why photos, image, video, audio, those things we are unable to send. Okay, then in critical applications. So why critical applications we are not using this thing now? So we are using radio channels and we are taking the data and we are pushing the data. Okay, every interval we are unable to take the data and unable to push the data. So instead of that, so I have to use some time gap. So which I explained now, some 100 devices there. So on that I have to use that time gap. Those things I have to do now. So on that basis only, I just mentioned that. So this is not usable for critical system. So consider we are using any automated car. Okay, so every single second data is very requirement for that particular decision making. Okay, so there I can enable to deploy this LoRa technology. Okay, then phone calls. So if I want to make a phone call with the help of LoRa and LoRaWAN, I'm unable to do that. Okay, then so while taking that OSI layer allied with the help of LoRa and LoRaWAN, so where it is allied on OSI layer, I have shown now. So on that you can able to see classes, class A, class B, class C, like this you can able to see now. So these are the classes. So what are these classes and what is the use of these classes now? So with the help of the classes only, what I'm going to do, I'm going to push the data, I'm going to take the data, those things I'm going to do. Okay. So how I'm going to utilize the window. So based on the utilization of window also, I'm going to get the power consumption. Those things will vary. Okay. So here I'm having 3 set of classes. Just give me a minute. Okay. So here you can see these are the classes. Okay, LoRaWAN class A, class B, and class C. Okay, class A. So where it is suited and where it is how you are going to use one. What is class B and what is class C? So those things we are going to see in depth in the later slides. Okay. So before that, I'm going to explain basic explanation, a line of this thing I'm going to give. Okay. So first one is a class here, which we mention as a class all. Okay. So this class all. So this class C we can use this for a battery operated devices. So battery operated devices I can able to deploy using this class E. Okay, so if it is a class E, I can choose battery operated device. Each device downlink will based on uplink of that particular one. Okay, so which means so RX1 window will open first, then only your RX2 window will open. Okay, so that is known as a class A. Okay, what is class B? Means same as class A, but the difference is it having extra opening time for my RX2 window, which is nothing but my downlink. Okay, then class C. In class C, so if I can I use the battery operated devices. So here we are able to use it because its name itself it is mentioned like class continuous supply it is required. Okay, so why? Because so all that downlink window, so which is not going to control with the help of uplink window. Okay, so RX2 window is not based on RX1 window. Okay, so that RX2 window will always be open on that particular instant. Okay, so that is the thing why it isn't power hungry compared to class A. So this also compared to compared to other technology like Bluetooth and Wi-Fi. So it consuming less power. But so why this class C I mentioned as a continuous supply is required now? Because that RX2 window will always open. Okay, so that RX2 window will always open. Okay, so that's why what I done. So I just make it as a continuous power supply. Okay, so here I'll explain all those things. Okay, so here you can see this graph of image, right? So this is my node uplink transmission. Okay, so here from this node, what I'm going to do, I'm going to send the data. Okay, so I'm going to send the data towards a network server. So for that, I'm going to use this RX1 slot. Okay, RX1 window. We call it as an RX1 window. Okay, so with the help of this RX1 window, I'm going to push the data like this. Okay, from there application server or network server, if I want to give the downlink, so for that I'm going to use RX2 window. Okay, so RX1 window is for uplink and RX2 window is for downlink. Okay, so that is the overall view of this image. Okay, so with this image I'm going to explain. Okay, okay. Okay, so if I want every 5 minutes uplink, so what I'm going to do, I'm going to set one uplink interval. Okay, so consider 5 minutes. So till that 5 minutes, my RX2 window and as well as RX1 window, both the window will be on closed state. Okay, so if I transfer the data, if I'm given the downlink will not reach towards you. No, it will be queued. Okay, and this method in first uplink, so entire device is on sleep mode. Okay, so whenever the timer triggers, so whenever the 5 minutes trigger, then only my node will wake up and it will take the data and it will push the data and it will wait for a certain time of certain period. Okay, the downlink receive, it will receive the data and it will progress, or else it will go to sleep mode. Okay, so this is the entire functionality how it's going to work. Okay, so it will take the data. When it will take the data, it will take the data depending upon uplink time which I'm going to give, uplink transmission time which I'm going to give. So for example, here I have given some 5 minutes. Okay, what happened till that 5 minute, my RX1 window, RX2 window nodes, all the thing is going to on sleep mode. Okay, sorry, this is closed, RX1 and RX2 is closed and my node is in completely sleep mode. So whenever the timer even triggers, so that 5 minutes triggers, then only my node will wake up. It will take the sensor data and it will push the data using this RX window one slot. Okay. After this, what happened? That data will go there. Okay. It will wait for another set of time. So consider if it is waiting for some 5 minutes, so it will wait for 5 minutes 10 seconds. Okay. So for downlink one. So if it is not, if I'm unable to get the downlink, then it will go to sleep mode, and next uplink will happen. In between, if I'm given the downlink in between, okay, what happened? It will queued in your network server only. It will not reach your end node. Okay, so whenever my this RX slot 2 open, from there, then only the queued downlink will arrive towards your node side. Okay, so this class A devices I can able to modify as a class B and class C devices. Okay, so if I depending upon the small changes only I have to do. Okay, and this class B and class C devices must be supported class A functionality also. Okay, so the functionality device same. The two windows only I'm going to use, but what is the difference between classes? So how I'm going to use this RX2 slot? So that is the major difference between these three classes. Okay, now I hope you are okay with this. So okay, I'm just going to class B, the same one. Okay, so here you can see my node is going to transmit, two windows going to be here. Okay, so what is this RX and ping period and beacons now? So this class B majorly is used for the tracking, those things, GPS location beacons. So there they are going to use. Okay, so beacons majorly they are using for beacons. Okay, so here what you have now, so it will work as like my class A. So once the uplink happen, then only the downlink will come. Okay, but here it is having an another option. So instead of waiting for that uplink, so every 1 minute I want to check the downlink now, so I can able to do that. Okay, so that same scenario here I'm just presenting. Okay, so one node is going to send the data, so I'm just set at my node time as a 5 minute. What happened? So every 5 minute only it will wake up, it will push the data, and it will listen for another 10 or 5 seconds. Then it will, if the data is there, it will receive, right? Okay, so if I'm given downlink, I have to wait for 5 minutes 20 seconds or 30 seconds. I have to wait. So instead of that, what I'm going to do in class C, I'm having an option is called a ping period. Okay, so which in betweenly I can able to slice the downlink. So how can I do that now? So for example, if I'm setting my ping period as a 1 minute, so what happened? So in between that 5 minutes of interval, uplink 5 minutes now, so in between that I can able to use with the help of the ping period. I can open the slot RX2 slot. I can able to take the data and it will go to off. After 1 minute, again it will open, take the data and go off. After 1 minute, again it will open and it will get the data and go off. So like this entire class B will work similar to class A, but that RX2 slot open and close will have the in between. I can able to open and close with the help of ping period. Okay, then next one is a class C. Okay, so what is this class C means? So the similar as class A. So here we are going to have a node transmission is going to transmit the data. Okay, then RX1 slot and RX2 slot. So like this, two slots you're going to have. Okay, that's similar as like this. Okay, so in what is the difference between class A and class B and class C means? So compared to class A and class B, what is the difference in class C now? So here you have RX1 slot. As per the scheduled time, it will work. So for example, 5 minutes. After 5 minutes, it will uplink the data. Okay, but after that, so here you can see RX2 slot. What happened? Remaining open until next uplink come. What happened? So this will always open till my next uplink come. Okay, so for example, after 5th minute, so it won't wait for 5 minutes of downlink. So 5 minutes of uplink, then only downlink will come. It will not like that. Before that uplink, my entire downlink window will be open, which states that your node will not go towards your sleep mode. It will always on wake up mode. Okay. So what happened? Power consumption is more. It will always listening on this radio. Okay. So what is this advantages here in class C now? So if I want to control something, okay, so I can able to I choose this option class C. So immediate controlling option, if I require, I choose the class C. Okay. So in between the 5 minutes, so if I given a downlink on 1 minute, it will reach, or 10 seconds it will reach, or 20 seconds it will reach. Okay, so that is the difference between class A and class C. Okay, so can you able to visualize why class A is less power consumption device and class C devices are more power consumption device? So in class A, your node will go towards a sleep mode, but in class C, your node will not go into a sleep mode. So till the next uplink, it will always listen and then uplink the data. Then also it will always listen for the downlink. Okay. So likewise, it is there. So that's why class A, we can use battery operated devices, but in class C, we are able to use the battery operated devices. So instead of that, what we can do, we can use we can use it as an power operated devices. Okay. And then next one. Okay. So if I'm transferring a data towards my network server, so addressing and activation, so I can use set of activation methods. What are the activation methods now? ABP mode and OTA mode. So these are the two activation methods which I can able to use on this particular LoRa to node to my network server data transferring. Just a minute. So that works. So here, activation methods. So if I want to transfer the data towards a network server, so I have to use some set of keys. Okay. So addressings. So how I'm going to address those data. Okay. So that is known as an activation method. So here I'm having two set of addressing and activation methods. So that is known as an OTA and APP. So OTA means over the air activation. Okay, over the air activation method, and ABP stands for activation by personalization. So okay, so based on this activation methods only, I'm going to take the data and I'm going to push the data. Okay, okay. So in OTA mode, so what are the keys it going to uses now? So device UA, app UIs and app keys. Okay. In ABP mode, device address, network session key and app session key. So what is the main thing here now? So here you can see, so here it is using EUIs. Okay, not a direct identity, it is using EUIs, but here it is using the direct address of the devices. Okay, so both the method is secure, but compared to APP, OTA is more secure. Why? Because it is directly using the device address. So instead of this thing, so here it is using EUIs. Okay, so that is the major thing. Okay, so with the help of these activation methods, what I'm going to do, I'm going to push the data towards the cloud. Okay. As previously explained how this thing will happen. So here you can see. So end devices. Okay. So end devices to gateway, radio communication, radio channels. It will convert the splitting data into radio packets that will push the data. So those things will happen in end device. In gateway, It will take the data and it will convert those data into an IP packets. Okay, after converting those data into an IP packets, those IP packets will transfer towards a network server. So from that network server, I'm going to transfer the data towards an application server using IP packets. Okay, so format may change, JSON format or tag format. So what are the formats you want? It will depending upon the network server, it will do. Okay, so basically, so we are using TTN, TTI, and TTM. Okay, so this network server will transfer the data from network server to application server in JSON format. IP only in JSON format. Okay. Okay. So here you can see from the image itself, you can see. So I'm using APP encryption mode. So network session key will help me to connect till the network server, and with the help of the app session key in that network, I'm having an application. So I can able to identify those application there with the help of the app session key. Okay. So I just open that thing and I'll just show. Okay, later. Okay. So here you can see N devices activation method. In this, the first word we are going to see is an ABP. Okay, so what is ABP? So and how I'm going to use this ABP mode of activation. So we have seen the keys, right? Device address, network session key, and app session key. Okay, so from my node, what is the exact device address? So I'm going to get it from there with the help of this device address itself. Okay, so consider I'm having a device address of 001, and 002 is next device, and 003 is next device. Okay, so it will directly take the data and it will push the data. But in OTTA mode, there what will happen? So instead of this direct device address, it is using UIs. Okay, so for every join request, that device address will be differs. Okay, so for example, first join request, it will give a device address of 45. On second join request, it will give a device address of 75. And third join request, it will give a device address of 100. So likewise, that automatically that data will changes. Okay, which is nothing but a node details. The node UI will change. So that is why here I'm using EUIs and here I'm not using EUIs. Okay, and network session. So I'll taking this image itself I just mentioned. So with the help of the network session key, I can able to exactly pinpoint the network address. Okay, network. I can directly going to the network. Then app session key. So in that network, I can able to create that application. So with the help of that app session key, I can able to log into that. Okay, just a minute. First, I'll just open that and then I'll show. Okay, so this is my network server. Okay, so how my node is going to get the data till here now? So here I'm just go here in device and node. Okay, here you can see network session key, app session key, and device address. So with the help of the device address, I can able to identify my device. My device will transfer the data till with the help of this network session key, it will transfer to this. Okay, in my node side. So whenever it join with that particular cloud, so based on that cloud, one home net ID will come. Okay, so for example, this TT stack, TT stack. So this TTN stack, you have a home net ID of 0x13. So which is nothing but 1313 is the stack address for this. Okay. So if you're going with some other network plus application server like activity, so that is different. If it is general, your home net ID will be 0 or 1. So if your node want to connect with all the devices, you have to generally use it as 0 or 1. Okay. So for thing stack, it will be 1 3. Okay. So whenever it connect with that home net ID will be registered there. Okay. So whenever I connect, it will automatically ping that and it will push the data. Okay. So with the help of the network session key, it will directly push the data till here. Okay. Network, it will push. Okay. Then what happened? It will push till my, wait a minute. Network, it will push the data. Okay. So now I want to visualize the data. So where can I visualize the data? I have to go to this application. So in my application, so here you can see I'm having two set of application. In this, which application I have to push the data? Okay. So for example, this is the thing. So this application I have to push the data. Okay. So what I've done, with the help of the network session key, I just enter into a proper network server. Okay. Then after that, what I'm going to do, I'm going to push the data towards this particular application, like WDM is my application. So here I have to push the data. Okay. So what I'm going to do, I'm going to push the data here directly towards that application scheme. Okay. So likewise, I'm going to do. So with the help of network server, I'm going to come into this network. And if I want to push the data towards this exact applications like WDM, okay, in my applications, I'm having a number of applications now. So here instead of here, so I want to push the data in this WDM now with the help of network session key. I'm going to push the data. Okay, so this is the entire thing. So how the data taken and it will push. Okay, it will happen. Okay, okay. So before jumping to another method, okay, so I want to explain. So I'm having one gateway. I'm having 100 sets of node. Whether that 100 sets of node will send the data towards that particular one gateway only. So is that like that? No? So not like that. If I'm having another set of gateway, okay, so consider the same gateway I'm going to get. So two different gateways I'm having. So all the node will transfer the data in that particular channel. So that address will not. Okay, so that node will not transfer the data towards that particular gateway only. What is doing? So it is taking the data and pushing the data in a particular common frequency channel. So which is nothing but 865.402.500. Who are all listening on that particular channel, they will grab the data and they will push the data. Right? So consider I'm having some three sets of gateway. I'm having one node. Three or two gateway. I'm having only one node. And it is transferring in a frequency of 865.4025. What happened? So the data will receive on gateway 1 as well as gateway 2 also. Okay. So here what is it is doing? So data duplicancy is happening. Why? Because so the node will not transfer the data towards a gateway. Okay, which means that particular gateway address. So it just emit the data on a common channel. Who are all listening on that common channel, they will get the data. Okay, so that is the thing. So node is transfer the data. So it will get the data in both the gateway. Okay, those data will transfer towards your application server. So here is the main advantage of the application server will come. What it will do, so not just the decryption only it is not doing, it also taking the data and converting those data, checking those data whether any duplicacy is there or not. So the same address, same device, same data, if it is come, it will make it as a duplicate. So what it will do, so consider one node, I'm having two set of gateway, taking the data and pushing the data to this gateway. What happened? So first data will receive from the number one gateway itself. Number two gateway also sending the data, same data. So what it will do? it will consider the first data and it will make the second data as a duplicated data. So that is the another main advantage of network server. So the first one is an encryption, decryption, and next one is the data duplicacy avoidance. Okay. So I already mentioned. So if I want to push the data towards an application server, I have to push the data in a JSON format. Okay. So for that, I have to retrieve the data, right? So from the network server, while decrypting, I'm retrieving the data, but it is in the hexadecimal format. Okay. So how can I send the data in non-hexadecimal format? I have to convert, right? So why I have to convert? So consider if I'm getting a data of 10 degrees Celsius. Okay. In my network server side, what is the data I will get? 0A is the data I'll get. So here I'm going to put it in the timestamps I'm going to push, right? So instead of that, what I'm going to do in the timestamps, I'm going to make it as temp equal to 10 degrees Celsius. So with the help of the payload decoder, our name is called a payload decoder. I'm going to decode those. I'm going to decode those ABP. Nothing but the hexadecimal data into a general data format. Okay.
Excuse me, sir.
Yes.
We were not able to
What?
see what you are explaining.
Sir, now only I'm going there, sir. Can you able to see my screen?
Yes, we were not able to see the hexadecimal code, but now we are able to see.
Wait, sir. I'll show. Wait. Just a minute. Just a minute. So here I'm just showing in another network. So whether any node is alive or not, I'm just checking. Live data transfer every 1 hour once. So let me wait for the data. Okay. So once the data arrive, I will just show. So every 20 minutes, once this data will arrive. Okay. So in application server, so how the data is converting those things, I will just show. Okay. Right now, let me. So from my node, what is the data it will transfer now? It will transfer the data, just the hexadecimal data only it will transfer. Okay. But with the help of a payload formatter. Okay. So what I'm going to do, so here you can see they have written the payload formatter. No? So with the help of the payload formatter, so I can retrieve the data. So it will come like a bytes. Okay. So here you can see byte 0 and byte 1 is for my battery, and byte 2 and byte 3 is for my temperature. So hexadecimal data, I'll get the bytes. Those byte data, I'll transfer, I'll convert those data into one real data format. Okay. So those data I can able to see in this particular one. Okay. So just a one demo login. Okay. So I'm just wait for it. So once the data came, I'll just show to you. Okay. Okay. Let it come. Okay. I'll check another network server also. Wait a minute, not this one. Here I'll check any data is coming or not. Then I'll just show that. No, in this one, no data is coming. Okay, no issues. I'll just show here. Okay, here you can see the data came, right? First, I'll just pause this. Okay, so here you can see. So this is the data which has been sent from my node side. Okay, so this is the exact data which I'm getting from my node side. So node 18 is transfer the data, and it is transferring the data like CB, F8 and 0B and 64 and 07. Okay, CB, F8, 0B, right? So here I'm going to hex to text converter, hex to text, sorry, decimal converter. So CBF8. So first 2 byte is for my battery. CB and F8. Okay. So here you can see 52216. So here these data, they will get the data and they will wait. Instead of that, some calculation they are written. So instead of that, I'll just show another byte. 0B64. 0B64. This is for my temperature. 0B64. So here you can see 2916. Okay, so in this they will add the decimal in the payload decoder. So my node, from my node, what is the data I'm getting? 0B64 is the data which I'm getting, right? Sorry. So 0B 0B64. This is for my temperature data. Okay, so this is the data which I'm getting. Okay, here in if I'm converted to 0B64, what it will give? So 2916. So they in this they will add the decimal. Now we'll see what is the temperature in that particular location. So here you can see 29.16 is the temperature. So how they are doing? They take the exact this particular hexadecimal data and convert those hexadecimal data into an some real data format. Okay, so here you can see temperature C of SST to 29.16. So this has been decoded here itself. So here you can see, so which I have highlighted now. So this one. So by 2 and by 3 is for my temperature, and they have divided, and they just show the thing. So now only it is added as a decimal. Okay. So 29.16 divided by 100. So see 2916 they divided by 100. What happened? 29.16 is the data which I'm getting. So likewise, I just written the payload decoder here. Okay, the real data. So instead of seeing the hexadecimal data, so with the help of payload decoder, I can able to decode this data. Okay, so likewise, you can able to do in this network server. Okay, so first one is an decryption. The next one is an data duplicacy avoidance. The next one is a payload decoding. So what are the payload I'm getting? I can able to decode the payload decode. Okay, so those things I can able to do. Okay, so in OTA mode, so what it will do, it's similar like how my APP works. It will transfer the data to a network server. Okay, but compared to this and this one, so what it will done now? So from my end node, first a join request will send. Okay, once the join request will go to a network server, then it will give one join acceptance message. Then only it will check the device address. Those things will happen. Then only we can able to take the data and send the data. Okay, so it's like a handshake. So it will send on acknowledge. For that, my network server will give one acknowledge. Okay, then only that communication between end node and the network server will establish, and it will transfer the data. Okay. So this is how ABP and OTA is working on. Okay. Then, so long distance goals. So how can I increase the coverage range? For better signal strength, what I have to do? So if I want to do reduce data loss, better signal strength is the thing. So low power devices means how can I do now with less amount of TX limited data. Okay, TX for limited data. Okay, so consider if my gateway is near to me, I don't want to transfer the node in a maximum power. Instead of that, I can choose a minimum power is sufficient. Okay. The next one, secured communication. So for the secured communication, we are using AES encryptions. Okay. Okay. So then, okay. So these are the main topic to increase the coverage and reduce the data loss. So what are the things we can able to do? So these are the main topic. So increasing EARP of the gateways. Okay. So that what is EARP? So how can I increase? Which is nothing but the power. So how I'm going to increase the power of those things we can able to see. Then mounting gateways in higher altitude. Okay, so which I already mentioned that. So in my particular location in my office, so I have located the gateway in the fourth floor. Okay, so one side compared to my office, there you doesn't have the fourth floor office or fourth floor buildings. So you have lesser height buildings. So what happened there? I'm getting long coverage. So, but another side, I'm having some bigger buildings are there. Okay, skyscrapers are here. Okay, so there, what happened? You unable to get that because compared to your gateway altitude, those building is very high and it is completely blocking your site. Okay, line of sight it is blocking. There you'll get less coverage. Okay, so for increasing the line of sight, so if I'm deploying the gateway in a open source with a good attitude, what happened? I can able to increase the long coverage. I can able to get. Okay, then better impedance matching. Okay, so based on your antenna and your circuit, if you created a better impedance matching circuit, then you'll get more coverage and reduce data loss. Okay. Okay, so I already mentioned that. So as per their countries, they have selected, they have given, LoRa Alliance have given some frequency. Okay, so who given the authority for that now? So the Troy is the person who have given the, which is nothing but the Troy, entire telecommunication. So what are the things you have to do? What are the protocols you have to follow? All those things, who is deciding? Troy is deciding, right? So the Troy has allocated these are the unlicensed band frequencies you can use for this protocols. So likewise they have. Okay. So the first one they have given is a 433 to 434 megahertz. So it's just the 1 megahertz that I'm unable to use efficiently. Okay. So instead of that, what I'm using 865 to 867 megahertz. So maximum transmit power up to 1 watt of maximum efficient radiated power I can able to use, and multiple channels I can able to use. Bandwidth maximum up to 200 kilohertz I can able to use here. Okay, so the general terms we can use only 125 kilohertz, but in case some major things, so we can able to use up to 200 kilohertz. 500 kilohertz not possible here. Okay, so only up to 125 kilohertz is more than sufficient here. Okay, then so what is my transmitted power EIRP we can able to use in our region? So 30 dpm of EIRP I can able to use. Okay, so for testing purpose this is sufficient, but for deploying, so we are using up to only 20 dpm. Okay, so for testing and development purpose we are using up to 30 dpm of EIRP. Okay, so these are the things in this frequency channels and EIRP which the LoRa Alliance which get approval from the TRA itself. Okay. So what is duty cycle? So why I have to go for this now? So I'm mentioning that line of sight is there. It will take the data, pushing the data from network server, from node to network server. So how much time it takes? So those things I'm unable to get now. So with the help of duty cycle, we are going to. So time taken from node till my network, that data transmission in between air time. So how much time it is taking? So we are going to calculate it now. Okay. Okay. So why we have to calculate the air time now? So depending upon the air time and spreading factor, the air time will varies. So for a single byte of data itself, air time will varies. Okay. So consider my node is in a weak link. So weak link means weak poor signal if it is there now. So it will transfer the data na as a factor of 12. Okay, why? Because that coverage, that node is present in the end of that particular coverage range. Okay, so that's why it will. We are using ADR, so adaptive data rate. So what happened? It will automatically set it as SFS12 and it will transfer the data. Okay, so those things it's going to happen. Okay, so here I just show one data thing. So 1 byte of data I'm going to transfer. What is the spreading factor I'm going to use now? General spreading factor. Initial spreading factor of SF7 I'm going to use. Okay. So before selecting the regional parameter, I just want to show one thing. So here I'm going to select EU. Okay. So here I'm going to select European. So why I'm selecting European one? So here you can see. So what is the frequency band of EU? 863 to 870. Okay. So what is the frequency band for us? 865 to 867. So U is, what is the U? 863 to 870. Ours is 865 to 867. So we automatically lies under EU, right? Okay. So that's why for the TTN network, so it doesn't have a router in India. So you can use European router to push the data towards your cloud. Okay. So I log into the TTN. You have seen I have selected EU, right? So once again, I just shown you TTN. Here you can see these are the servers available. So here I'm choosing European server. So here for India, it doesn't have any server. So instead of that, I'm using European server. Why? Because automatically my entire frequencies lies under EU. So I can use that now. So that's why I just select the European frequency. Okay. So here what I'm going to do, I'm going to select my region as EU868 and bandwidth of 125 kilohertz. Okay. So what is my data is going to present in airtime is 46.3 millisecond. 1 byte of data only I'm going to transfer. So if I'm transferring 1 byte of data in a spreading factor of SF7 and in a bandwidth of 125 kilohertz, so it is 46.3 milliseconds. Okay, the same thing. Okay, so this consider this node is present near to my gateway within a kilometer it is present. Okay, so consider now my gateway one node is going to present in a end circle of that particular coverage range. So it is transferring the data SF12. So here you can see the same thing, 1 byte of data only is going to transfer in a spreading factor of SF12 and bandwidth of 125 kilohertz, same as this, but here spreading factor is different. So here you can see what its airtime. So its airtime is 1155.1 milliseconds. So for SF7, it just 46 milliseconds. So if it is an SF12, it is 1155 milliseconds. Okay. So by this, what I want to conclude now. So if my spreading factor is more, so my spreading factor is SF12 or like this, your data is going to present in an air medium is going to be on higher amount of time is going to present in the air. Okay. If a radio signal present in the air or if a signal present in the air, okay, is more, now what happened? Automatically noise will occur on that particular signal. If noise occurs on that particular signal, what happened? Data loss will happen. So that is the thing. So if a data present in an air time is more now, probability of data loss will be more. If a data present in air time is lesser now, probability of your data loss will be lesser. Okay, so that is the thing. So by using this calculator, I can able to calculate the air time. Okay, so I'll not tell that SF12 is was one we unable to use that. Likewise, I'm not telling. Okay, so we can use this SF12. Okay, so if I'm setting my entire thing as an SF12, okay, so static one, what happened? So data loss will be high, but more coverage range, more increasing long distance I can able to achieve. So if it's a spreading factor of SF12, see SF7, so I can reach around 2 to 3 kilometers. So consider in open space. So if I am setting my spreading factor as SF12, I can able to cover up to 6 to 7 kilometers. So double the amount I can able to do. Okay, but in SF increases, data loss will be there. Why? Because the air time, the data in the air time is very, very, very high. What happened? It will just a minute.
So why is higher frequency used for a longer range then?
Ma'am, it's not a higher frequency, ma'am. It's a spreading factor.
It
So the
takes
same frequency only I'm going to use. So that's spreading factor, adaptive data rate. So instead of
that's having higher subband, right? That's at the higher subband.
No, ma'am, subband is same. Okay, so the subband is same. What are the band? I'm going to use the same band, same frequency only. So the spreading factor will defined by the transmission power. The transmission power, the spreading factor will help out. So what will happen? So spreading factor means, so if I'm setting a minimum spreading factor now, your transmitting power of that particular gateway is less and your node is less. So consider it's around some 14 dBm. Okay. So if I'm setting my defaultly gateway spreading factor will be more. Okay. So it will be around 20 dBm long range it will cover. Okay. So if you want to use a minimum gateway power, you can use a static one, you can set as a spreading factor 7. So if you want to increase longer coverage range, then you have to set your spreading factor as a more than SF12 you have to set. Okay, so that is the thing. So depending upon power, this spreading factor will okay. So that's why in node side, gateway side, we defaultly make it as an maximum power of 20 dBm. So lesser thing also it can get more power. More power it is radiating. So longer distance it can able to achieve. In node side, adaptive data rate we have to set. So depending upon our thing. Okay. So default values we can able to set. So like S of 6 or S of 7 or S of 8, S of 9, likewise we can set. Okay. Or else you can choose an adaptive data rate of 1. What it will do? It will automatically defines that. Okay, so depending upon the signal strength, SNR and RSSI of that particular signal, it will automatically setting the spreading factor as an S of 12 or as of 9. Okay, so if so consider here I'm saying now one side of there I'm having bigger buildings, so there SSI, RSSI and SNR is very poor. So from if I'm having any node from there, so it will transfer the data in a spreading factor of 12. Why? Because RSSI and SNR is very poor there. So it is considering as a longer distance node. Okay. So likewise it is working. Okay. Okay. So add time calculator we have calculated. Okay. So for node, how much time it going to take? So for process, hello. Yes. Okay, so complete cycle. So how much cycle is going to take and it is going to do? No? So complete cycle. So for an end device, okay. So end device will take 5% of time, and receiving device will take 5% of time. So totally 10% of time will taken from the node side itself. So remaining for single node, if it is a 5%. So remaining 95 percentage is going to do in the air medium itself. So consider, so 95 percentage of my air medium time is 530 milliseconds. So totally 50 seconds it will take. Okay. So if it is an uplink and downlink, if a duty cycle is taking a 10 percentage of time is taken in the node side itself, what happened? So 10 percentage node processing time and 90 percentage is going to happen on your node side. Okay, so this is the entire duty cycle from node till network server. How much time it will take? So node will take 5%, and the receiver will take 5%. Totally 10%, and 90% is your add time. Okay, so likewise, I can able to calculate the entire duty cycle from node till gateway. Okay, that RSSI and SNR, this entire thing will varies depending upon environmental factor. So that's why before we deploying any gateways, so we'll go for a range test, the better RSI and SNR. Okay, so depending upon the environmental factor, it will affect. Okay, so that entire thing will affect. It is an RF communication, RSI and SNR will affect. Okay, so that's why before deploying the gateway, so we'll not theoretically we are not randomly say. So everywhere you place 3 kilometers will get. Likewise, will not give any assurance to customer. So depending upon customer's place only, we can able to identify, because RSI will different RSI and SNR there will be different. If it is a noisy environment or a dusty environment, okay, so those entire thing can affect those things. Okay, so because it is an RF based communications. Okay. Okay. Then EARP. So we already know what is EARP. Effective isotropic radiative power. Nothing but a power level of my gateway. Okay, so how we are calculating a power level of the gateway? Okay, so always my transmitting power is going to be an 18 milli. So I'm setting as a maximum 18 millivolt of my transmitter power of my gateway is going to be a 18 milliwatt. Okay, and cable loss is 1 dBm. Okay, so here we are using optical cable for that antenna connection, those things. Okay, so which is going to be an 1 dBm. Okay, and antenna gain. So what is the gain I'm going to use? So 3 dB antenna is there, 12 dB antenna is there, 5 dB antenna is there. So which is that 3 dB, 5 dB, 12 dB. These are the gain parameter of that particular antenna. So if it is a 12 dB antenna, I'm getting 12 dBm of power. I'm getting. I can able to achieve long range, good RSA, good SNR. I can able to get. If it is a 3 dB antenna, so lesser compared to that one, I'm getting lesser. Okay, so likewise, this entire antenna gain, cable loss, and transmitter power is fixed 18 millivolts. So depending upon that, my EARP. Okay, so that radiating power of that particular antenna will be differs. Okay, so if the antenna gain increases, radiating power of that antenna also increases. If the antenna gain decreases, radiating power of the antenna also decreases. Okay, so depending upon the site, we have to select that antenna as per the place. Okay, so either 3 dB antenna or 5 dB antenna, 12 dB antenna, we have to select. Okay, so these are default one. These remaining two parameters are default one. This antenna we are going to choose as per the environment. Okay. Okay. So how to increase LoRaWAN
Why
coverage?
have you shown the power transmitted as 18 milliwatt? That is the standard, or
That is the standard fixing value we can able to set it in gateway. Man. So the
okay,
maximum up to 18 deployment cases I'm telling. Okay. So 18 milliwatt we can able to set transmitting power. Sorry, radiating power of the gateway. Okay, so in testing case we can able to increases depending upon our cases, so depending upon the gateways. Okay, so here I'm having multiple gateways, single channel gateway is there, multi-channel gateway is there, outdoor gateway is there. Entire thing parallel will be different depending upon the gateway models.
I thought I saw 10 milliwatt in one of your slides.
Which one, ma'am?
I thought I saw it as 10 milliwatt in one of the slides. Was that the...
Ma'am, that's why I'm not using this one. So here you can see 433 to 434 megahertz I'm not using.
Okay.
So here you can see maximum effective radiated power is 10 milliwatt.
Sorry.
Okay. So that's why I'm using 865 to 867. So how to increase LoRaWAN coverage? Okay. So what are the cases, and as per the cases I have to deploy. So that's what it's purely based on environment which we are going to deploy and coverage, that environment going to look. So based upon that, I can increase the LoRaWAN, that signal strength coverage I can able to get. So first slide here, you can see propagation through obstacles. Okay, so even though I'm having some, now I'm placing a gateway on a fourth floor. Near to me, within 100 meters, I'm having one bigger building. Sixth floor building is here. Okay, so after that, okay, I'm having another set of building. Okay, after that building also I'm getting the data. Okay, a bigger building is there, but I'm getting the data. What happened? That signal will penetrate through the building. Okay, and I'm getting the data. So if a signal penetrating through some obstacle, what happened? Automatically the signal strength will be reduced due to that obstacles. Okay, so the best example is you're using your mobile. So if you're placing your mobile in an outside, so you'll get 100 full tower you'll get. Okay, so if you're placing your mobile in some concrete place, okay, concrete roof, if you're placing your mobile now there, you'll get only 1 point of signal coverage only you'll get. So why? Because so that penetration of that particular signal strength on that concrete is very high. Okay, so that power there itself it reduced. Okay, so signal strength there itself it is reduced. So that's why that coverage range will reduce. Okay, so via buildings, if it is penetrate through this building obstacle, that is different. Tree, that is different. If it is a some dense obstacle is there. Okay, so consider some concrete building or mountain, like a dense building or dense obstacle is there. So there you will not get any data. Okay, so why? Because this entire dense thing itself completely washed out my signal strength. So likewise, it is going to happen. So this is known as a propagation through obstacle. So if it is propagating through obstacle, this is the thing is going to happen. Okay. Next one, propagation through reflection. Okay. So even though if the data is falls on the building and it is reflected back, there will be some um, signal that signal strength will be reduced because it will false there. Okay, then as per that for a example, if it is a false on some building, okay, then it will reflect back. But while it is false on that, so it having some signal strength of, consider a signal strength of some random values like 10. Okay, so if it is taken after it is reflected from my building, so it may be around 8 or 9. So what happened? Automatically, my signal compared to direct signal, reflected signal strength will be less. Okay, because of the interference in between them. Okay, next one, the diffraction. So nothing but signal will go there and fall in the higher altitude and reflected back. So the same as reflection. Okay. So what happened? So here also I'm having the same thing, that signal through diffraction. What happened? Instead of direct signal, diffracted signal having lesser signal strength. So that's why while placing the gateway, so we have to analyze that environment. Okay, so whether any taller building is there, any bigger tree is there, or any mountain is there. Likewise, as per that, I have to choose the antennas, and then I have to choose the higher altitude buildings to place the gateway. Okay, so consider we have deployed in one industry. Okay, so in industry, name is called Dalmia Cements. Okay, in Trichy. Okay, so there we have deployed the gateway in a height of 13 floors. 13 floors of height, one chimney is there, so there we have deployed the gateway. Okay, so in one side of that plant we have cover till end of the plant we have covered, on another side we are unable to cover it. So why? Because so similarly there will be another obstacle, that 9th floor chimney is there. Okay, on another side. So that's why what happened, that entire chimney will block that entire coverage, not a entire coverage, it will block the coverage. After the chimney I'm getting the signal, but my and the RSSI and the SNR is the worst RSSI and worst SNR I'm getting. Okay, so like this, so it is reflected back and I'm getting the thing. Okay, even though if it is reflected back or penetrated in that particular chimney, I'm getting the signal, but it is a weaker signal. Okay, so that's why uh, depending upon environment and where we are going to deploy that, we have to select antenna DP, which gain antenna I'm going to use, and which altitude I'm going to place. It's very, very, very important as per deployment cases. Okay. So next we are going to see direct signal and Fresnel zone. What is that Fresnel zone? Why this Fresnel zone plays a major role? Those things we'll see. Okay. So Fresnel zone is nothing but, so it's a radiating pattern of that particular signal. Okay. So did the node radiate in a single direct pattern or not like that? So it will entirely radiated in some oval shape of pattern. Okay, so in that pattern, so if a signal having any obstacle, what happened? Reflected back or propagation. So those things will happen. Okay, so propagating through that particular wall or likewise it will happen. Okay, so that's why the Fresnel zone is very, very important. How I'm going to place the gateway and how it's going to happen. So in the second image, so here you can see, so the signal set is falls on the ground and it will reflect it back to the gateway. So if it is like that, what happened? Automatically my signal strength will reduce. So nearly some 60 percentage, 60 to 70 percentage of operational zone is free. So it will directly pinpointing the gateway. So remaining 20 percentage is under the ground. So what happened? So it will falls on the ground and it will reflect back to the gateway. Okay. So likewise, it's going to happen. Okay. So if I want to have an 100 percentage operational zone without any interference, then what I have to do? So I have to place the gateway and node on higher altitude. Is this possible? Is this the right way now? So not is there. So for example, consider I have to deploy some sensor nodes. Okay. So if I want to deploy the sensor nodes in agricultural fields, okay, some soil moisture sensor or pH sensor or TDS sensor. So I have to put that on that particular field. So how can I make this professional zone as a complete professional zone without any interference or reflection or anything? So how can I make that now? So I have to make the gateway attitude high. So while increasing the gateway attitude high, so that will be a possibility to reduce your particular obstacles. In the second image, I'll just show that. Okay. So here you can see I'm having a node which is placed on the gateway. So in between, I'm having one obstacle. Okay. So here you can see I'm having one building obstacle is there. But what I have done, my antenna gateway placement, the entire gateway and antenna placement is higher altitude. What happened? My fractional zone is slightly sideways. It will have sideways it is connecting. Okay, so directly the data is transferring towards the gateway without any obstacle it is doing. So that's why, so based upon the environmental factor and that customer place, we have to identify the exact height, attitude, and then your dB. What are the dB of antenna? What are the gain antenna you are going to use? 3 dB, 5 dB, 12 dB, based upon that customer place and environmental factor you have to decide. Okay. So if I'm placing the gateway there, okay. So after a week, a heavy rain comes now. So on the day, I'm having getting some data loss. Why? Because that environmental factor automatically changes. Heavy rain. Okay. So it reduces. It also blocks that RSS index and all. Okay. So not on 100% data loss you will not get. LoRa data loss you will get. Okay. So if it is properly setted one, so if I'm transferring some 100 set of data I require, so nearly 90 data, 85 to 90 data will get. Okay. So remaining 10 or 5% of data will be lost. Okay. So depending upon the case and how I'm going to deploy this, it's very, very, very important. Yeah. Okay. Okay. Okay, so if I'm not properly installing that, okay, some professional zone, half of the professional zone is has been blocked by some obstacle. Then what happens? Means, so here you can see. So consider my node and gateway. I'm deploying not at a higher altitude. Just general altitude I just fixed. Okay, so here you can see professional zone of my node. Okay, nearly 60% is clear fractional zone, direct line of sight I'm having. So remaining 40% it is blocked. What happened? The signal will false and it will reflect it back to the gateway. So if it is like that, what happened? Automatically covering distance also reduces. Okay, so that's why what we have to do, we have to placing the antenna in a gateway and antenna in a higher altitude. So with this tabular column I can show you. Okay, so here you can see 100% clearance fractional zone. So maximum up to 10 kilometers I'm getting here. Okay, 60% clearance, maximum 6 kilometers I'm getting. Actually this data we have taken in a test environment. Okay, so test environment is different and deployment environment is different. Okay, so in test environment doesn't have any obstacle. Okay, so likewise we have these have been tested. We have not tested that particular LoRa alliance. They have the LoRa guys has been tested. Okay, so test environment is completely different. Okay, in that case you will not get any obstacle on their climate, on their environment. That entire change is different. So there they have given a 10 data. So how they mentioning this as a 10-kilometer radius they have gathered the data now. So if they transfer 10 set of data, okay, so even though in the 10th kilometer 9 data loss happened, even one data arrived, so they will consider as a 10-kilometer of radius it can able to achieve. Okay, so that is the main thing. So that is why I already said, so 10-kilometer is a theoretical part. Okay, so 10-kilometer we can able to achieve without any obstacle, direct line of sight we can able to achieve, or higher gain antenna, even more 10 kilometers also we can able to achieve. But the thing is, what we have to do, so that is depending on that particular environment. If an environmental change, any obstacle is there, then automatically your coverage range will be reduces like this. So 60% of clearance, 6 kilometers. Yeah. Okay. So we have deployed these gateways, those things in a number of multiple customers like farming and industries. Okay. So then smart cities, smart campus, like I say, a number of things we have deployed the gateways. Okay. So on that basis only, we have defined that. So in that particular agricultural land, so I doesn't have that much of bigger trees. Okay, so it's just purely farming land. Okay, on that land, I'm getting nearly 5 to 6 kilometers of radius. A single gateway is covering 5 to 6 kilometers of radius. But in the same gateway, in my top of my office building, it is covering maximum up to 3 kilometers of radius. Why? Because here more obstacle is there. Okay, more obstacle is there, and I'm having different environment here. Okay, so that is the main thing in this. Okay, then after this, so these are the hardwares which I have explained. So how that the data will take and how the data will push. Okay, so like this, n number of things is there. Okay, so n number of products we have. Okay, so if you want to explore the LoRa and those things, so you can go to our website, multiple products, or else if you want to use any deployment cases, so I'll just show the products, a number of products we have. So these are the products. So this is an energy meter. Okay. So consider, so instead of taking the seeing the energy meter reading and taking the data, some person come and take the reading and they tell us. So instead of that, what you can do, so you can use this energy meter. Sorry, so it will take the data and it will push the data directly towards the cloud. Okay, so I'll just show one example. Actually, till yesterday I have tested one energy meter which is deployed in our room. Okay, I'll just show in our room fish tank. I'll just show the entire data. So what is the thing, what is the voltage, what is the current, entire thing I'll just show. Different login. I'm in different login. Wait. Okay, so here you can see. So till yesterday 5 nearly 6, I'm getting the data. Okay, after that I just switch up that. Okay, so here you can see. So my meter ID. So this is a consumer ID of my particular energy meter and current consumption. Okay, so which we have off. So that's why my current consumption is 0. So in my meter itself, I'm having a relay option. So if I want to cut off the particular current supply of that particular room, I can able to cut off, and kWh and frequency. So all those details I'm getting from the particular thing itself. Okay. So like this, I'm getting the data. So here you can see the still how much kilowatt hour of power consumption I have done. Okay, for the past month. So 262 kilowatts of current consumption I have done. Okay, then what is the frequency? What is the voltage? And what is the current? So I have just switched up that. Okay, so that's why. So I'm getting this. Okay, current and meter status, whether it is on or off. Now meter is in off state. Okay, so likewise, entire thing you can able to do with this particular energy meters. Okay, development board is there. LoRaWAN develop mode is there. Okay, so this is a soil pH sensor, and this is a distance reduction sensor, temperature sensor. Okay, then this one a liquid level sensor is there. Okay, NPK sensor is there. Okay, ECTDS sensor is there. Temperature sensor is there. GPS tracker is there. Okay, and there's one IO controller. So if I want to control some 230-volt appliance, so here I'm having that relay module is there, so I can able to control. Then RS485 module is there. Okay, so whatever the product, these are the products which are available in our website. Okay, so if you have a time, you just go through it. So if you have any POC, so you can choose as per your POC what are the hardware you require, you can choose. Okay, so here I'm having ready to deploy nodes are also available, development nodes also available. So based upon your use case, you can. Okay, so by this I just conclude the session. So whatever the doubts you have, just put. Okay, so here I'm just giving the feedback link. Wait a minute, it's just loading. So I'm giving the feedback link. Okay, so after the completion of session, we just list down it. Okay. So you just list down what are the things about the session. So likewise, you just list down. Okay, so I just put the feedback link. So whatever the doubts you may have, you just ask now. If you have any doubts, you can ask. I just post a feedback link. Okay, so in the chat box.
Sir, if we want to use this LoRaWAN for agriculture application, so how much would be the cost required? Is it economically viable for an ordinary farmer?
Ma'am, so initial cost is a little bit, as a consumer wise, if I say na, initial cost, okay, initial cost is little bit high. Little bit high means, so you have to spend, for example, some 3 to 4 parameters you are mentioning. So you have to send 4 to 5,000 for a node, and some indoor gateway setup. So likewise, if you deploy na, then after that, maintenance cost is very, very, very less compared to any other module, GSM, Zigbee or Wi-Fi. So their maintenance cost is very, very high. So here, no maintenance cost. Okay, so that is the main advantage of these technologies. Initial cost may think it's may high, but maintenance cost it's low. So that is the thing. One time installation. That is the thing.
Okay, okay.
Hello.
Yes, sir.
Yeah, I have one doubt. Already you have talked about the antenna and how to increase the range of the antenna. We can use the antenna for 22 dBm to 29 dBm. So I have one question.
Radiating power of that.
Yeah, that's the radiating power, I know. You suggest a gateway in your slide which is Dragino gateway. Is there any possibility to change the antenna in single gateway, or the Dragino gateway is designed for a one antenna, only for one antenna? My question is, can we change the antenna for the Dragino gateway?
Yeah, sir, you can change the antenna, sir.
With I know there are.
What is the gateway you are having, sir?
Actually, we have used Dragono gateways. But
That was, sir. What is the gateway, sir? Gateway model.
Dragono DLO is, I think.
DLO
DLO
is
is
3 dBm antenna is there,
3D.
5 dBm
Yeah,
antenna is
3D.
there. So defaultly it will come with 3 dBm antenna. So if you require 5 dBm antenna, you can put 5 dBm antenna there. It can support 5 dBm antenna. You can put.
Okay, we have another ground plane antenna also. Can we connect that antenna? Is there any design?
Sir, RF antenna 865 MHz tuned antenna is required, sir.
That's okay. But in Dragono hardware, there is some antenna. Is there any antenna design or anything provided in the Dragono gateway itself for connecting the fiberglass 3 dBm and limited
Sir,
to
that
that?
was, sir. Impedance matching circuit is already present in that particular gateway itself. So for 3 dBm and 5 dBm, it's already present. Okay.
Okay.
So if you want to put that 5 dBm antenna, you can directly take and you can directly replace. So regarding the 12 dBm, I'll check. You just mail to IoT and IoT support at enthetech.in. Regarding that 12 dBm, I'll check with the team and I'll let you know. So 3 dBm, 5 dBm internal impedance matching circuit is enough. So you don't need to change anything. So for 12 dBm, I have to check with my team and you just mail to IoT support at enthetech.in. Okay, then we'll reply back on that.
Okay, fine. Thank you.
Any other participants has any doubts or clarification?
Sir, when you simply change the antenna to higher gain antennas, does it ensure a better range in all directions, or is it just
That's what, ma'am. It is based on environment and what is the place we are deploying.
Yeah, so when you deploy something like 10 nodes or something, do you do a field test for all the 10 positions of the nodes and then only deploy the gateway? Is that how it is done normally?
Normally, we are deploying some large scale things. So there, what we are doing now. So for each and every node, we'll do the case. So where the customer required, they'll tell the place. We'll check the RSA and SNR how the coverage is there. So if the coverage is fine, we'll go with that. Or else, what we'll do now, we'll suggest. So here, one gateway is not sufficient. 2 gateways required.
Yeah, that is fine for fixed deployment, right?
Yes.
What if you're going for because I was thinking of something like a water quality monitoring. So when you think of such a thing, you need to have some kind of a dynamism in the system, the node itself. So in which case, this replacement of antennas or changing the gain dynamically, that won't work, right?
It won't work, man. So we have to check. That was the thing. So, or else you just mail us, man. Okay, we will just check the possibilities. So, are there any other possibilities there? Like this, we'll check and we'll back to you, man.
Great. I filled that form. Yeah. Thank you. Thank you, Praveen.
Thank you.
Anybody else? Okay, we have shared 2 forms. One is from Enterprise Technologies, so please fill that form. Feedback form from our part also is there. So kindly take time to fill both the feedback forms. So I take this opportunity to thank Praveen Kumar for handling the session.
Thank you, sir. Thank you.
I want to thank Hindu Technologies also for their cooperation in providing us a right resource person for this session. I hope it was beneficial to all of you. So this comes to the end of the first session of the day. In the next session, we will start at 1:30. We have again a resource person from industry handling the session on edge analytics. So kindly join by 1:25 p.m. We want to start the session at 1:30 itself. So please join at time. Thank you. Thank you all.